good few questions on that now. Okay. The first one, if y was equal to the log of a over b, right? That's the same as the log of a minus the log of b. The rules of logs says that the log of a over b is the same thing as the log of a minus the log of b. If I said to you y was equal to the log of x plus 2 over 2x minus 1, before you differentiate, you'd say that's the log of x plus 2 minus the log of 2x minus 1. So now dy dx is equal to, and that's just two separate sums, because if they are added or subtracted, they are differentiated separately. How would I differentiate the log of x plus 2? It's a chain rule. It will become 1 over x plus 2. And how would I differentiate the log of 2x minus 1? It's a chain rule. It will work out to be 2 over 2x minus 1. So I have two simple chain rules. So now I have it differentiated. It's over. Had I not used the rules of logs, what would I have to have let u equal to? X plus 2 over 2x minus 1. And how would I have differentiated that then? The quotient rule. So I'd have introduced the quotient rule into this when I can just use the rules of logs. That's equal to, add them in an LCM, it's x plus 2 times 2x minus 1. X plus 2 will divide in here. Once 2x minus 1. Minus 2x minus 1 will divide in there. 2 times x plus 2. So that's 2x minus 1 minus 2x minus 4 all over x plus 2 times 2x minus 1, which is equal to minus 5 all over x plus 2 times 2x minus 1. That's one rule of logs and how it would impact on your differentiation. Any questions? All right. The next rule of logs is, if y is equal to the log of a by b, I can say that's the same thing as the log of a plus the log of b. If y was equal to the log of 2x plus 5 times x plus 3, before I differentiate that, I could say that means y is equal to the log of 2x plus 5 plus the log of x plus 3. And I've now separated it into two different sums. Otherwise, I would have had to let that be u. And how would I have differentiated u? A product rule. Then dy dx is equal to, the log of 2x plus 5 is a little chain rule, 2 over 2x plus 5. Plus the log of x plus 3 is 1 over x plus 3. Which is all over, it's just algebra now. 2x plus 5 times x plus 3. 2x plus 5 goes in here. Twice x plus 3. Plus x plus 3 goes in there once. 2x plus 5. Which is equal to 2x plus 6 plus 2x plus 5 all over 2x plus 5 times x plus 3, which is 4x plus 11 all over 2x plus 5 times x plus 3. Now those two rules do make the differentiation shorter, but not by an absolute massive amount. This is the rule that makes the biggest difference. If y is equal to the log of a to the power of b, well then y can be written as b log a. Yes? So if I said to you y was equal to the log of the square root of x squared plus 3, I can say that means y is equal to a half the log of x squared plus 3. Because the square root means the what power. And that's a rule of logs. I've done no differentiation, but now I could differentiate it. Dy dx is equal to a half of. How would I differentiate the log of x squared plus 3? A chain rule. And it will give me 2x over x squared plus 3. The 2's will cancel. I'm left with x over x squared plus 3. Otherwise, that would be a chain rule. What would I have had to have let u equal to? The square root of x squared plus 3. And how would I have differentiated the square root of x squared plus 3? A chain rule. Yes, with. So I'd have had a huge amount of work, so it greatly simplifies it. This was on the papers in the past. Y is equal to the log of that. If I come across logarithmic differentiation, what is the first thing I will ask myself? Can I use the rules of logs? So I can use that rule. It's a half the log of x squared plus 1 over x squared minus 1. And then I can use another rule to say it's half the log of x squared plus 1 minus the log of x squared minus 1. So how many rules of logs have I used? And then dy dx is equal to 1/2 of the log of x squared plus 1, 2x over x squared plus 1, little chain rule, minus the log of that, 2x over x squared minus 1. Now it's algebra, it'll be a half outside it. All over x squared plus 1 by x squared minus 1. X squared plus 1 will go in there. And x squared will divide in there, which is equal to a half outside of 2x by x squared and 2x by minus 1. And minus 2 by that. That's a 2x, isn't it? Minus 2, 2x cubed minus 2x. All over, multiply them, you get x to the 4 minus x squared plus x squared minus 1. I knew the difference of 2 squares. So it's a half outside of minus 4x over x to the 4 minus 1, which is minus 2x over x to the 4 minus. Had I not used the rules of logs, I would have had to say u is equal to the square root of x squared plus 1 over x squared minus 1. And y would be equal to the log of u. Yeah? So then I'd have to differentiate this. How would I differentiate this? This is another chain rule. But part of it is what? The quotient rule. So you would fill pages. Yeah? 2 pages later, you wouldn't be near this answer. So again, before you do any logarithmic differentiation, what question do you ask yourself? Can you use the rules of logs? Alright? And there are all of the examples that I have given you there now, and how to use the rules of logs to greatly simplify. ln and e to the x are the inverses of each other. If you had y equal to the ln, if you had y equal to start an example there, if you had y equal to the ln of e to the 5x, that's just a 5, yeah? The ln and e, that's 5x. What do the ln and the e do to each other? They're the inverse. They're like a squared and a square root. Right. The final type then is when you have a constant to the power of x. If you have y equal to 3 to the x, how you must differentiate this is you must get the log of both sides. So the log of y is equal to the log of 3x. Therefore, the log of y is equal to x log 3. Do you understand what I did there? So I got the log of both sides, 3 to the power of x. What do the rules of log say you can do with that? It's x log 3. So then you get the d dx of each side. Alright? So I must get the d dx of log y is equal to the d dx of x times the log of 3. Differentiate log y. 1 over y by dy dx is equal to, how do you differentiate x log 3? That's it. Well, log 3 is a constant. So if that was 5x, what would my answer be? 5. 10x, 10. Log 3x, the log of 3. So therefore dy dx is equal to the log 3 times y. That's a divisor, become a multiplier, which is log 3 times 3 to the x is the derivative of that. Right? Now, we used to do a branch of differentiation known as implicit differentiation, which we don't do now. So I want to explain this 1 over y dy dx. If y was equal to a to the power of x, we will get the log of both sides. Right? That's how you differentiate it. So therefore the log of y, the rules of log say it's x log a. Of course I know the log of a is a what? A constant. Yeah? Is that okay? Now, here I have log y. Right? Log y, you can only get the d dy of log y, which is 1 over y. In other words, if I had x squared plus 5x plus 10, I can only get the dd, I can only differentiate that with respect to x because it's x. So because that's y's, I can only differentiate it with respect to y's. But I'm trying to get the d dx of both sides. The d dx of log y is equal to the d differentiating with respect to x, the x log a, because of this x here. You can't do that. So the best thing for you to learn, you can only get the d dy of that, yes? So that becomes 1 over y, but a dy dx has to be added in there to cancel it. It's the only place in the course you'll have to be able to do that. Is equal to x log a, log a. So therefore dy dx is equal to the log of a by dy dx, y, which is the log of a times y, a to the x. So you just say it's log a times a to the x. In case you come across a constant to a power, right?